We're here today to discuss addition, subtraction, multiplication, and division using algebra tiles. So, my algebra tiles represent integers. So, the green is for go, represents positive numbers. Red is for stop, that's going to represent negative numbers. So, one of the key concepts using algebra tiles is something called a zero pair. What that means is, think about your friend. Your friend gives you $1. So, you're holding your dollar and you're really happy. But then you remember you owe your other friend $1. So you pay your friend the $1 that your other friend gave you, and you're left with $0. So a zero pair is where a negative number and a positive number cancel each other out. I'm sorry, -1 and a positive 1 cancel each other out. They're a way of representing 0. All right, so let's talk about addition. So we're using algebra tiles to model integers, like I said. So let's do this. What I have is +3 and plus +2. So there is no zero pairs, so we're just going to tally up and get our answer. So 1, 2, 3, 4, 5, they're all green, so that means they're all positive, so 3 plus 2 is 5. Very straightforward. You're going to find it similar when I'm adding two negative numbers. So -4 and +3. And -3. So again, no zero pairs created. So we're just going to tally up and get our answer. 1, 2, 3, 4, 5, 6, 7. They're all red, so my answer is -7. Now, let's talk about when I'm mixing up and I'm adding a positive and a negative number. So, I got my -2 there and my +5. But now notice I can create zero pairs. So I'm going to do that. And remember, my zero pairs, they represent 0. So what I have is 0, I have a 0 there, and I'm left with 1, 2, 3, +3. All right, let's try one more variation. Our -4 and our +3. So let's get this problem out there. -4 and +3. Anytime we have a positive and a negative number added, we're going to create those zero pairs. Anytime we get a chance to, we're going to. So 0, 0, 0, those cancel out, and we're left with -1. All right, let's move on and talk about subtraction. Zero pairs are also going to be very important there, but we're going to start with the straightforward again. Remember, subtraction is really about taking things away. So we're going to model our problem. I have a +4. In subtraction, the first number represents what you're starting with. So I have a +4, and I'm going to take away +3. What am I left with? +1. Well, we're going to find that this one's really similar. I'm going to start with -5, and I'm going to take away -1. What am I left with? 1, 2, 3, 4, -4. All right, now let's mix up our signs a little bit and see what happens. So let's model the problem. I'm starting with -5, and I'm going to take away +2. But oh wait, I don't have +2. So we're going to create some zero pairs. Remember, zero pairs represent 0. So by adding them on there, I'm not changing the problem. I'm in essence adding 0 and adding 0. And adding 0 to anything doesn't change it. But now I have two negatives. So I can take away my two negatives. I'm sorry, I said that wrong. I can take away +2. 1, 2. And what am I left with? 1, 2, 3, 4, 5, 6, 7. I'm left with -7. So let's think about this. When I subtract a positive from a negative, I'm getting a larger negative. Let's remember that rule for future reference, guys. Now, let's switch it around. What if I have +7? 1, 2, 3, 4, 5, 6. That's not 6. Oh, there we go. 6 and 7. Yes. Yes. All right, now I want to take away -2, but I don't have any negatives. So I'm going to create zero pairs again. So remember, I'm adding 0, I'm not changing anything, but now I have negatives on there and I can take away two negatives. So what does that leave me? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm left with +9. So for future reference, we just made a rule. A minus negative becomes a plus. All right, let's move on. Let's talk about multiplication. All right, when we talk about multiplication, we're talking about groups of numbers. So the first number is going to represent the number of groups we have. And the second number is going to represent what's inside each group. So what this means is I have 3 groups of 2. So that starts out pretty straightforward. I'm putting on here 3 groups of 2. No zero pairs. Let's count them up. 1, 2, 3, 4, 5, 6. So my 3 pairs of 2, 3 groups of 2, represent 6. 3 times 6 equals 2. 3 times 2 equals 6. Let's do it again. Now this time I have 2 groups of -3. So now my groups are -3, and I have 2 of them. Let's do that. Let's tally things up. 1, 2, 3, 4, 5, 6. So my 2 groups of -3 represent -6. All right. Let's actually do that one next. Let's talk about this. What if I have the negative number first? What that means is I'm going to be taking away groups. So what I'm doing is taking away 3 groups of 3. So let's make some 0 pairs, guys. Let's start with some 0 pairs. All right, almost there. Let me just put 2 more on there. All right. So what I'm going to do is take away 3 groups of +3. There's 1 group of +3. There's 1 group of +3. There's a 3rd group of +3. What that leaves me is all negative numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. -3 times +3 is -9. All right, let's try another variation where I have a negative times a negative. This time, I'm going to be taking away 4 groups of -2. So let's create our 0 pairs, because if there's nothing out there, I don't have anything to take away from. Right. Okay, let's see. So I'm taking away 4 groups of -2. There's 1 group. There's a 2nd group. There's a 3rd group. There's a 4th group. What am I left with? 1, 2, 3, 4, 5, 6, 7, 8. But notice they're positive. So real quick, let's reiterate some rules here. A negative times a positive was a negative. A negative times a negative was a positive. So we have 2 groups here when we talk about the signs, guys, with multiplication. Anytime the signs were the same, our answer was positive. Anytime the signs were different, our answer was negative. And now we kind of see why. All right, last thing we're going to discuss, division. All right. With division, I'm going to kind of look at it a different way. Remember, division is kind of backwards when it comes to multiplication. We're working backwards. So when we're looking at this, the first number we're going to think of as our goal. The second number is going to be how many groups we add if it's positive or remove if it's negative. So I'm going to add, because it's positive, groups of 3 till I reach my goal, which is 9. So I have, there's a group, there's another group of 3, there's another group of 3. So what I have is, how many groups? I added 3 groups of 3. All right, let's see if this works again. All right. So notice, guys, now that I'm adding groups of 2, but my goal is to reach a negative number. So let's make some 0 pairs. All right. Can you pause yours? Or is it pausing? It will stop. All right. Sorry for the interruption there. Okay. So now my goal is to get to negative 10. And I'm going to be putting in groups of negative 5. So 1, 2, 3, 4, 5. There's one group. 1, 2, 3, 4, 5. So I added 2 groups of 5, negative 5, in order to get negative 10. So my answer is positive 2, because it took me adding 2 groups of negative 5 to get negative 10. Let's make sure we're clear on this, guys. All right, so my goal is to get to positive 4, and I'm using groups of negative 2. So let's get my positive 4 out there. But I can't take away negative 2, so I'm going to put some 0 pairs out there. But I have to keep my goal in mind. My goal is to get to positive 4. So I'm taking away groups of negative 2. So how many groups did I take away? I took away 2 groups. And since I took them away rather than added them, my answer is negative. Let's make sure we're clear on this one more time. All right. My goal is to get to negative 6, so I'm starting with that. And I'm going to create 0 pairs, because I can't take away positive 2 until I have some positive 1s on there. So let's take away groups of positive 2. 1, 2, 3. So it took me 3 groups of positive 2 to get to negative 6. But since I was taking them away, my answer is negative. All right, guys, I hope this helped. Key things to remember: when you're modeling, 0 pairs are very helpful. Good luck.